Guten Tag, ich begrüße Sie zu einem neuen Interview, in dem es heute nicht ausschließlich um CAD-Software und BricsCAD geht, sondern um das Bauwesen im Allgemeinen. Mein Gesprächspartner, der Architekt Tal Friedman, stammt aus Israel. Deswegen werden wir das Interview ausnahmsweise in Englisch führen, für Sie als Service mit deutschen Untertiteln. Bleiben Sie dran, es wird sicher interessant. Today, we will discuss the future of AEC industry with Tal Friedman, an architect and designer. He's working in the field of parametric design with an emphasis on structural systems. His folded structures are somewhat inspired by Japanese origami. Besides of architecture and design, he is active in automated algorithm-based design to fabrication. Good afternoon, Mr. Friedman.
Good afternoon, Mr. Lantzsch. Thank you very much for hosting me. It's a great honor to be here and connect with the community.
Today we want to talk about the future of AEC industries. 10 years ago, a new topic came up, Industry 4.0. It's a broad discussion, but it's very limited to the production, let's say, of machines and cars. Is it today time for, let's say, architecture 4.0?
Yes, so thank you very much for that question. I think it's exactly the right time. And I think that you mentioned, Industry 4.0 as being the kind of catalyst for a new way of manufacturing. And the big difference between architecture and industrial manufacturing is that in architecture, as I like to say, no two buildings are alike. When we look at the manufacturing world, we see that robots excel when they have to create automated, repetitive objects, right? And if you have a car, you can maybe customize the leather seats, but in the end, you're talking about the same car being replicated over and over again. In construction, I think we have an opposite situation where every building has to be customized or should be customized for the needs of the user, for the sustainability, and for the construction method and context where we are building. So I definitely think it's time to use digital tools to allow us to take those same tools and that same revolution that has happened with Industry 4.0 and bring it to an age of construction 4.0.
In Industry 4.0, the digital twin is a big topic. In construction or architecture, we have the BIM concept. Will BIM change the way we are working?
Okay, well, that's a broad question, and I'll start with saying that every process or every change of one field has to do with the change of another. And I feel that for BIM to change the way we build has to change BIM. Meaning that when we look at BIM today, we are seeing basically a representation of geometry, and we are seeing a platform of design that does not necessarily include our means of manufacturing within our design process. So I think in that sense, it would be very hard for us to talk about changing how we build before we, I would say, inform one another. So if I should take it to a more practical level, as a friend of mine likes to say, BIM is people, right? BIM is basically a bunch of very acknowledged people in their field working with BIM software, enhancing their knowledge within or inputting their knowledge within the software. And I think that the next level would be where we would embed the information from the actual construction components within BIM in order to automate the design process. Now, for this to happen, I think we first need to look at our means of manufacturing. And you were talking about Industry 4.0, where we are designing for robots in that sense, right? We're designing for the machine. So form follows function in manufacturing is not only about the function, but also about the manufacturing process. And I feel that in construction, we are using elements that are designed for the human hand and for the tools that are on a human scale. And in that sense, it's very hard to go and talk about a robotic revolution or an automated revolution where we are still designing with our software for the scale of the human hand. So I think once we inform our BIM to those new means of manufacturing and we create things that are optimized for manufacturing, then BIM will be able to change how we build.
You were talking about robots. Do you think this is a future development in construction as well? So can we learn something from industry? Let's say robots, what about 3D printing? There were concepts using 3D printing on the moon or on Mars to build houses for the astronauts to follow. Is this a suitable way?
Well, I think for me, it's a bit early to talk about Mars. I think there's still a lot
No,
of work to be done.
I think on Earth. Will we have robots on construction sites on Earth?
Exactly. So I think I've seen a lot of interesting concepts of 3D printing and also building on Mars. And I think as a concept, it's very interesting. I'm more of I would say I do consider myself a utopian, but a realist utopian, which means that I always like to go into the screw level and check out if this utopia is realistic. And I think if we look at the lineup of technologies that we have today, some of them are very interesting in their digital approach, and yet when compared to our traditional way of working, sometimes they will fall short in their actual, let's say, performance on the market. One of them is 3D printing. I think the idea of 3D printing is wonderful as long as you are enhancing three-dimensionality and free-form design. And yet when I see things that are being done on an extrusion level, I would always compare it to using a mold, right? Because if you're going to make an extrusion of a flat wall, I'm not sure where 3D printing would be. And I think that's always the question that you have to ask, like, what is the end result? Because if you made an extruded building and it's 3D printed, but you show it to somebody on the street who's not an architect, who doesn't know anything about parametrics, design, and he sees a straightforward extruded building, I think that is where we would fall short in our ability to optimize robotics.
When you're talking about structures, innovative structures, and we can talk about your own work. What is your, you have a Voltstruct logo there. What is your, let's say, approach to if you have a new project?
Okay, so my approach to architecture in general is a parametric one, and I'll try to explain what that means. So when we look at buildings today, we're seeing a kind of process of building one block on top of the other, where we are kind of estimating what will be built, but it's a process that is, I would say, a gradual process. The parametric approach talks about a DNA of a building as a product that can be adapted without having to build it from the ground up every time. And when you create that DNA of a building, you also get something that is very adaptable. And I always look in my work for the, I would say, morphology from the word morph, the ability to morph the building. So if I notch down the DNA of a building well enough, it will not only be an extruded version of a block. It will be able to dance, it'll be able to move, it'll be able to take up different variations. And that's, as an architect, what I always look for, things that will make, the heart of people sing. It's not just about construction. We forgot about the word architecture. So I would say I look for the variety, right, within the structure, not what the building is, but what it could be. as we understand it to a very high degree, and don't have to, I would say, limit ourselves to a box.
Can you give us some examples? How are your customers reacting? Have you have some recent projects, and must be a sort of a different approach you're talking to your customers because they're used to something else.
Exactly. So I would say that the question splits into two. First of all, there's the shock, right? When people see something that is completely different from what they know, they're automatically, I would say, afraid of something new. They're afraid of risks, and they are hesitant of their ability to do something different than what they've done before. And this is exactly where Foldstruct comes in order to help them reach those goals, improve everything, and solve all the problems using digital tools. And I'll explain in a minute how we treat the problem, because there is a very large problem. If you look at 99% of the buildings, they're built exactly the same, more or less. They're using the same components, and yet everybody talks about the need to build different, right? So when you design the same thing over and over again, you are likely to get the same result. And that's what Einstein, I think, was talking about, where he said insanity is to do the same thing over and over again and expect different results. So I think, firstly, it has to be said that the way we are going now is probably not the right way. And that's judging by, the EU figures and stats. To say that's what I know, that's what I like, we no longer have that privilege, because the world is going to a place where we have to be more efficient, we have to save. We're also seeing the result of building repetitive blocks and architecture where people don't want to live. There we see socio-demographic results that are not sufficient, and the cost that we have is sometimes much bigger than the saving in construction. So just to refer to what you were saying, we're building digital tools that allow the designer, right, to actually approximate the construction process and the price at a very, very early stage. So there is no longer SketchUp, there's no longer 3D Max. Everything is combined together with a BIM. Whatever you designed has a price tag, it has building components on it. Everything is basically an adaptable product, right? And that's the innovation that Foldstruct brings, is not only in its design, but in its process, in linking the fabricator together with the designer in one process. And I think this is the big mindset that changes. When people see the design process, then they understand, well, if I have all the components nested down, if I have from the beginning stages everything, in one, it would be much easier for me to believe that I can actually get this done.
So before you will show us some of your projects you did, let's come back to software. We are here at BricsCAD. So
Exactly.
what would you need from software like BricsCAD BIM or other suppliers to work perfectly in your concepts?
Okay, so I'll give an example because I should say we're also developing software that work with software like Brixis. And I'll say it in a kind of in a way to describe the vision. I think we're living in an age of HTML, right? Let's say if we compare it to programming of websites, where we want to go to the age of what's called Wix, or template design, right? We today are beginning from scratch to design every building. We have to make design choices from zero. BIM software is basically, as I mentioned before, a geometry platform, but it's not a decision-making platform. It doesn't help me make better decisions. It doesn't make decisions for me. And I think what we as architects and in general, what the industry is looking for is a more unified approach to a building. Not to say this is an architect, that's an engineer, that's a fabricator, that's sheet metal, right? So it's not that I finished my job and I hand it over to the fabricator, but we are working on the same model. And when the fabricator made his nuances on the project, he informs my model. And so our approach is a unified approach it's a circular approach and not a linear in that sense.
Okay. Thank you very much, Mr. Friedman. I'm really looking forward to see some of your examples now. Thank you very much for your time.
Thank you. So in this part, we're going to be talking a little bit about my work in construction, design for manufacturing, and BIM, and how everything kind of connects together in this new age of construction 4.0, the age of AI and construction meeting together at one point. So if we look to the past for a second, we can see that we had quite a lot of visions back in the early days about what robotics are, where this age will lead us to. It was a utopia / dystopia, depends who you ask, but it was very clear that a change is coming. And I think it's time to jump to reality to see where we are today. And we can see that we are already at a point where robotics have created a giant leap forward, and yet we on the manufacturing side of construction have been left behind, where technology is pretty much pulling the rug under our feet. So what does this mean for our industry? How do we match this need for a global demand for advanced buildings together with these new technologies? Because we see that there is a huge demand. These kinds of buildings are created in very specific areas in the world, and we have to basically bring that question up of how these technologies can help us get to the type of architecture, the type of engineering that we want. So unfortunately, this is what happens under the hood of most of these buildings. And it's an amazing project to begin with when we speak about the engineering behind it and the huge efforts. And yet that is exactly the problem, that these efforts are still not feasible for mainstream construction. And if we want to see more projects like this, we have to think about simplifying the design and fabrication. In reality, 99% of the buildings look much more like this. They're too expensive to build, they take too long, they're too polluting, and they're too dull on an architectural level. So Einstein said that the definition of insanity is to do the same thing over and over again, and expect different results. And yet this is what we are doing in construction. If we continue to design the same buildings, we will continue to see the same results. And what are these results? 40% of the world's CO2 emissions created by the construction industry. And I'll say that number, millions of buildings will be built and renovated in the next years. And we have to understand that number, millions, because that means that there's a lot of things we can change, and the impact is much greater than we can even imagine. So tens of billions of dollars are being spent on these energy reduction programs, and we as architects, planners, designers, and engineers have to see how we can match our designs and our buildings to these goals. So the main problem that we have right now is that we are designing for the human hand, as mentioned before, and we have to think about designing for machines. That's a huge leap in our understanding, because how do you teach an architect to design for a smart factory? Is it really realistic? So I'm going to show you a couple of examples throughout this presentation of different methodologies of how, when we use these types of technologies and these types of parametric workflows, we can get much closer to thinking like a smart factory. So it all starts with thinking and talking to a machine, because when we design something on the computer, that thing in the end has to be manufactured. Of course, BIM has brought with it great advancements in the ability to design almost anything we want, and yet now we have to come to the age of automation. The great reward of automation, of course, is that we can save 30 to 50% of the planning cost with cutting design fees, engineering fees, and consulting fees. If we create repetitions and create smart manufacturing, we can decrease CO2 emissions, and we have seen this in other industries. And now let's look at how we could implement those in ours. So 1921 and 2021, the leap here between the old car and the modern car, it's about 10 times cheaper, faster, and greener. And how have they reached all of that? Through the age of automation. So if we look at the gap right now that we have in the BIM world, it's to bridge that gap between digital design and manufacturing, to use those robotics, and to create a complete workflow between what we, the designers, are creating and what the guys and girls on the manufacturing floor are doing together with robots. So moving from part design, where we designed individual parts, to design for manufacturing and assembly is the key. Moving from pure geometry, which is where we are today, moving away from the domino effect, where we are always moving linearly, to an age of the butterfly effect, where everything is linked. When we make a change in fabrication, it will already affect our initial design and vice versa. So I like to call it the building as a product, everything in one. In a parametric model, that basically means that there's no longer that difference between initial design and the design for manufacturing model, where today we have maybe a year or 2 years gap between the two in planning times. So when we talk about repetition and customization, of course, that's the biggest thing we have to overcome, because not all buildings are created equal, and we cannot think of a building as a car, because a building, has its own restraints, and every building is a little bit different. So in the work of the office, we like to look at modular systems, and in general, I would say fabrication technologies as potential for parametric systems that can change. So a modular system that you see here is comprised of many repetitive elements, and when they're stacked one on top of the other, we see that we're getting these repetitive elements that, of course, have a very inherent architectural problem in them. And this is our version of using parametric workflow to use the same types of modular elements stacked one on top of the other, just in a different way. And here you can see that using that type of mechanism, we can achieve buildings that have this kind of free-form flow to them. They allow us to still use all the advantages of the repetitions together with architectural values. And I think that's the secret for us to find, basically, right? To understand that it doesn't mean that everything has to actually look the same if it uses the same components. Here's another building that we are working on right now, which basically we are creating this diversity in shading, which relates to sunlight. And you can see that it's actually based on a flat curtain wall, and you get this kind of optical illusion, and yet you still allow the building to behave as a standard building and be feasible for the contractor. So here we really try to find, I would say, the variance within something that is very rigid. So the software part that we work on is always trying to ask these questions of how to move from a sketch, and how to dream, and how to allow the architects to have that magic moment and go from their sketch to a digital twin in as little clicks as possible. So now you're going to see the input in front of you, which you already see, but now look at the output. So all of this was done in just a couple of clicks using our parametric software. And what this allows basically is not only the design aspect, but also the bill of materials and a complete BIM model ready for, let's say, fabrication or assessment for fabrication in just a couple of clicks, without having to have all that knowledge about parametrics. So we really try to, I would say, bridge the gap in knowledge between what people want and what they actually need to have in order to push the project forward. This is a project that was done to kind of check a new system for fabrication, where we used the origami principles. This is also where the name Fullstruct comes from, because that was kind of the beginning of the journey. Here we took a 4mm thin sheet and used origami techniques in order to reduce all of its substructure and create something that is completely freeform and freestanding at 4mm thick, cut, fold, and assemble. We did that together with the Lucabond And now this has far-reaching applications in the field of facades and other types of structures. So we managed to reduce the labor and time by 3. We managed to increase the precision because we took off all of the part of the welding and a lot of the hard parts about fabrication through using these folded mechanisms. All of that was actually created parametrically with unique algorithms that allowed us to optimize the design for the fabrication. And in the end, we got something very, very interesting that was a first of its kind type of element that reduced all of the substructure. And I think that is really the beginning of the things that you'll see here throughout the presentation. One of these is a project that we just got recently where the developer came with this project. They wanted us to give them a different version very simply. So in just a few clicks of a button using our parametric workflow, we arrived at something like this, where you can see that it's actually built on top of the same building, but just a different facade. And again, using that same knowledge that we have in our system about rain screen claddings, about folding mechanisms, we're able to give designs like this that are completely adaptable and can match any type of design. So you can see this from another angle here. In the end, of course, when we talk about this, we're not just talking about the design. We have to talk about the assembly. We have to talk about the manufacturing. And here in this slide, you can see the type of workflow that we have in mind when we design this. We're already thinking about the manufacturing process, about the robots, about the bill of materials. If you're not thinking, in a holistic way, you're bringing yourself to a bottleneck where the fabrication will limit you in the end. So you always have to think, about the end result, how to ship, and every decision that looks trivial in the beginning becomes a very, very important one in the end, and it's better to have the fabrication knowledge in the beginning in order to incorporate that in the initial design. So this is a building, a pavilion that we have in planning right now, made of wood, where the idea was really to match this kind of free-form shape using wood planks, using really as little fabrication joints as possible, and I would say being as natural as almost vernacular as we could to create this kind of interesting shading pavilion in the middle of the nature. And that was really a big challenge, because when you're designing something that's free form, you have to kind of create a pixeling algorithm. And of course, that algorithm can be used in many other types of projects, and that's just one of them. So you can see here experimenting with lighting a little bit. I think that's one of the most interesting parts, is always to see kind of the magic part where the lighting comes in. And of course, today with renders, we have much greater opportunities to visualize. So I think, if you look at the details a little bit, you can understand how this works and how this could also be scaled and used on different types of projects. And this is what we are working on these days, these types of projects that create in them this kind of DNA that others can also use, and releasing those tools out to other architects and engineers to, in the end, create ideal buildings. So I want to, with that, thank you very much for your time. I hope you enjoyed the presentation. If you have any questions, feel free to reach out, and it's been my pleasure to present here to you. So thank you very much, and I hope you enjoyed. Bye-bye.
Vielen Dank für Ihr Interesse. Wenn Sie noch mehr über BRICS-CAD BIM wissen wollen, schauen Sie doch mal auf die Community-Plattform cad-deutschland.de. Interessantes über die Arbeiten von Tal Friedman finden Sie auf foldstruct.com. Für heute sage ich auf Wiedersehen und bis zum nächsten Mal.